Good afternoon. Thank you very much to the organizers for inviting me. Unfortunately, I came only around noon, so I missed all the interesting talks of this morning. The last one was particularly interesting for me because I will explain you in a minute. I'm a physicist by training, but I fell into high-performance computing, large computing infrastructure, large computational problems fairly early, considering the domain I was in. And just to see also this connectivity between disciplines is quite fascinating. Nevertheless, this talk, I believe, is going to be different than most that have been here today. I'm not a data scientist myself. And I'm here maybe to give a certain view about what kind of technology, the technology is there to help actually making the progress that all the research that, for example, has been presented today allows. But it's also pitched into an area more that has to do, what is the transformation that the data center are faced to be able to grab all the good innovation coming out from research and development. Also for, in the end, social and economic growth. So I'm myself, just briefly, I'm a pure product of academic universities in Switzerland. I did a plasma physics PhD many years ago. Then I went into high-performance computing, as I mentioned. And I've been driving for 5 years, for example, the Swiss National Supercomputing Center. I did work at CERN, but as a computer scientist more than a physicist, because it was a slightly different kind of physics that I was trained in. And I joined Intel 7 years ago into the data center group, which data center is developing and producing and selling the technology to the integrators then for the data centers. And we see really a big shift, and this is what I would like to share with you. What are the implications as of today? So what is the data center business about? We like, every group or company or organization has its own way of looking at things, so we like categorizing into different areas. So I'm mostly working with the right-hand side, government, academia, science, what we call technical computing. So by training, by nature, by affinity, this is where I'm probably also more relevant. But this has an impact on different areas, such as enterprise IT, because there is some innovation, of course, that also percolates inside the industry. Cloud service provider, now also the frontiers, the borders between cloud and what is really high-performance computing are blurring a bit. Communication service provider is something that we don't work too much, at least not in the area of the labs that we are involved with for the moment. So what do we supply here? These are on the horizontal, you see the bricks that we supply. We supply for the server, the computational elements. I think Intel is well known for, since 50 years, for providing a large number of computing platforms and chips. Storage, network, software. We are also a big partner in software. And we like developing proof of concept by taking some of these different bricks elements to really pursue and go at the frontiers of what is possible to do, as I will explain you in a minute. The big drive that we see since a few years are definitely the cloud, HPC and data analytics. Just to give you an idea of what the market looks like for HPC, the IDC company, for example, always put the price tag at around 11-12 billion per year that is being invested and developed for HPC. So it is a big market. It's important. It's important not only for companies such as ours, but it's important for the industry. It's important for driving, again, the development, for having better product, fastest product, or for research and academia, or even, of course, for having a weather forecast that is completely efficient for the security and for the safety of the population. So in that area, there are some elements that are making this the growth year after year, of course, some push. And now we see quite a bit push in the area of artificial intelligence, data science, and machine learning. We feel that as a community, we have to learn quite a lot together, how really to get to, for example, rendering the service that simulation has been doing since 20, 30 years in certain areas. I mentioned weather forecast is one of them, that the benefits have been reaped since quite a bit. But definitely there is a capacity really to grow further, and this is where we have decided also to move our cursor. So business, something is a bit wrong here, but since the business really success relies so much on IT transformation, and I will give one example of that. But just these are, for example, the area at the bottom. You see the areas that are being most impacted by this fusion between different elements. High-performance computing used to be maybe a few years ago up in the corner for people that needed really very sophisticated computers to solve DFT or computational chemistry or other sort of tasks, and up to the desk computer in some of the engineering offices. But the onset and the capacity to collect always more data, and data that is richer, data coming from different, either from observation, data coming from all the sensors that are coming in. This necessity to merge this is really a challenge. I was discussing recently with some people that were, for example, working for a very large world leader power supplier. So they have very large infrastructure to make the simulation. And this is what they used to call HPC. And of course, they have very large infrastructure for managing the network. And they have very large infrastructure collecting the data coming from the grid. How to merge that in the future? To have really, for example, capacity to be able to deliver and regulate the power on the network according to all the different parameters. Coming from the society that needs power, but also coming from the people that are producing power, rejecting on the network, for example, the element that come from the climate, from the meteor, producing power with wind turbine. For example. All that is fascinating, and honestly, I don't know if anyone today would know exactly how to do it. You may find people that claim they know exactly, but I think there is still quite a bit to learn, and that's what makes it very interesting. So I'm sorry that there is a bit of overlap here, but nevertheless, we are really living in a world that in which the business as usual is moving quite a bit. There are many companies, as we say, that know that they need to go through what they call digital transformation, and actually also the workforce. And there are many representatives here of young students, young PhD, young scientists that will work for the next 20 or 30 years making this change. And they will have to live into this world that, in which the data center is really changing for a number of things. You know, the workloads, as we said before, it was really very much siloed. Now we have the capacity to have the workloads moving from one platform to another, and the need often. It will have to be also self-aware in the sense that knowing, discovering the kind of platform it needs, the best platform it needs to go. Storage. I mean, storage used to be something you have, at the end when you end up your simulation, or where you take all the data from the field, from the observation, and then you analyze sometime. Storage is also changing completely because of the onset of different technology arriving. There is a 5G, of course, for telecommunication, all the software-defined storage. There is more and more intelligence being put into the storage system. Intel has announced the onset of new memory and the storage capacity based on 3D X-point technology. And all that makes really also the old idea that would make about storage a move. Network as well. The network, from the HPC connecting, I was discussing during the break about topology. The topology about, developing clusters in which you have a regular topology connecting all the network. This would be more HPC or cloud. But now we have the network that needs to bring back all the data from the edge, from 5G devices. All this data needs to be reunited, used, and given back as much as possible, and reused again. And finally, yes, because of this capacity to integrate different technology on the software side, coming from deep learning, analytics, neural networks, without even touching quantum computing, which is a very interesting thing per se, but it's different than the topic that I want to address here. There is quite a bit of challenge. So how does a company like ours contribute to enable this transformation. Because it has to do a lot with innovation, and innovation, the source of innovation is in the industry, in the industry R&D, and of course in the universities and in the research centers. Having an open ecosystem is very important. I will show you why in the next slide. And also the capacity to scale is very important. No solution can be confined into one territory now. We need to have this capacity to see, to envision how to scale it. Because business and research is accelerating also the need and the capacity to produce results and to do better simulation. So we have developed, for example, this synthetic map to see this transition that is happening. You see from what was before, for example, the data taken at CERN on the big LHC and the previous machines. So it was very much siloed, although it was they developed the concept of grid that became an incarnation of the cloud. But you have descriptive analytics. So on this side, the infrastructure, you see it scaling out. So from the silo, you get to virtual integrated appliances up to software-defined infrastructure and HPC. On the vertical side, it's definitely the question of the maturity, what you can do with the data. So from the descriptive, diagnostic, get to predictive analysis. We had, for example, an interesting project with how to reuse the data produced by the HPC machines. HPC machines are not that sexy per se, but they produce a lot of data that data during the runs that can be used to, for example, address or anticipate the problem of failure, many different components, failure, maybe couple also with environmental data, you know, with all the sensors that are regulating the humidity, the temperature, and all that. So this is all very interesting and willing to learn on that. So this is getting quite mature, up to get, of course, to prescriptive analytics and cognitive. So the strategy, for example, that we have is that we can work with customers and with institutions to integrate all or part of the different component that we propose, both in the area from the computer up to the software. There is no need to have the whole chain, but depending on how and what are the objectives that are being defined. This is, for example, one collaboration that has been took place last year with the Montefiore Health System, in which this is in the United States, to develop a modern data hub built on the Cloudera enterprise, which is one of the solutions to do the data management and the data analytics. Very much is a statistics tool, a sophisticated statistics tool. And there were a number of achievements that were obtained thanks to this collaboration that gave rise to a few papers. So again, you know, the different, so our strategy is from the hardware. You know, we are a silicon company. So from the hardware, compute, memory. Now we also have a product in the area of computer vision, up to the fabrics to connect all that. Libraries that we develop, and those libraries make then the installation of the framework. Most of the frameworks open source. For us, the open source being a player and contributing to the open source is also very important. So that the customer, the user, can use whatever framework he wants to use there. He or she is guaranteed to have, let's say, the best performance by if he wants to reuse the product that are underneath. On the tool side, we have announced. And Intel bought, I think, 1.5 years ago, the Nirvana company in deep learning, and there are some development going on. There will be some specialized hardware. And up on the top, you see the analytics solution, which are definitely depending. These are dependent upon the domain that all this architecture is being used. Another example of collaboration, which happened in the area of deep learning with the Princeton Neuroscience Institute collaboration, there was a fascinating development, understand how the mind emerged from brain function, analyzing then medical imaging. And that gave rise to, for example, publication of an open source Python toolkit for doing the analysis of neuro images. So what makes artificial intelligence hard and fun? I think being all trained in science or engineering, we like being challenged. First of all, it's a fascinating time to also to look for better model building. We need to find more efficient, pervasive model deployment. Now, the way all this workload branches onto the underlying architecture is very interesting for a computer equipment supplier like us, because there are many ways in which we can use better, more efficiently, sometimes even with less power, a certain architecture, including, for example, reducing the numerical precision when it's not needed, or reusing less memory, and all these different tools are now part of the software stack that can be reused, and of course the productivity and scaling, the needs of AI, and I'll give a few examples later on. So why do we want and why are we engaged with the community? This is an interesting study that I found into a publication that I think that came out in September last year. There's many data in there, but I found one that was particularly interesting, said the community is not vendor forum, but the top source of information for data scientists and ML developers. So that means that, and we know that from the HPC experience, that we really need to work as well with the developers, with the universities, with the training centers, where the innovation also starts, emerges, and understand where the open source, where the community is going, what are the needs, and work with them. And that translates into, for example, we have a number of programs. This is not exhaustive, but these are the best probably relevant to this community. For example, the Intel Parallel Computing Center, we have here an example, which are activities which we work with the scientists in optimizing and making a new release of their software that would run very, very efficiently on a number of platforms. We have a whole community called XPUG, which is completely open. You can go on xpug.org and download. They have 3 or 4 events per year, and you can download the presentation. And you will see that from HPC, it's also moving more and more in the area of machine learning and AI. We have academic programs, and we are part also of efforts in the open HPC software stack. Because we feel that we learn a lot more. And this is an example, XPUG, as I said, xpug.org. Just have a look at their website if you're interested into the event. They go around the world, 3 or 4 per year. There is always one in Europe. Another example of how we learn. So, for example, at CERN, you're probably familiar or aware that they take a lot of data, of course, from when the accelerator is working, and they store this data and they need to analyze the data. In order to reconstruct the trajectory, they compare with what they call data that is simulated. They do a lot of Monte Carlo simulation in order to identify what are the events, and they try to match with the signals that come out at very high rate from the LHC. Now, this has been the model since 30, 40, 50 years, probably from the time CERN, although it has been refined. But as the capacity of the beam to go to higher energy, more dense also capacity to have the hadrons collide, they will reach a certain time at which the simulation won't be that efficient. At the moment, the big installations, grid included, they probably use 40% of their time by doing the simulation. As the rate, the data rate accelerates and the density and the event, when the energy increases, the events are getting more complex, so more difficult to analyze. They want to really explore the way, for example, convolutional general adversarial network, so machine learning, can replace simulation in the future. I find that just quite fascinating. This is an example of what they have been presenting in one of the XPUG, so in which they explained they were doing Monte Carlo simulation, and because of the data rate increasing, now they need to explore by 2025 how can they can replace that by machine learning. And of course, all the validation will take quite a bit of time. And they are developing a deep learning engine for fast simulation. We are working with them on this topic. And this is, it will probably not be the only big experiment that is faced with this question. Probably maybe the square kilometer arrays or some others would be also interested in the long run, or even in the medium run, to find out with them whether the machine learning can replace or complement the simulation. So to give you an idea so we have, for example, in recent years, we have established collaboration with certain areas in Europe, starting with HPC. This was already quite a bit, but the more recent one is in Edinburgh with actually the Alan Turing Institute. And these are collaborations that we have with leading scientists in order to really learn about specific areas. And the one, for example, with the Alan Turing Institute in Edinburgh, I'm not working directly with this one, but you see it started, I think, 2 years ago, our collaboration. And 2016 with Intel strategic partner for ATI. And really the major areas were to focus on how can the algorithm that the scientists at Edinburgh and ATI are developing, how can they help also us to understand where the workload of the future are going? What are the features? What are all the different specifics that can be useful? Because we know this is one of the forefront on which innovation that will then drive a lot of the development and a lot of the usage in the scientific era will come. Now for 2018, there is apparently a new chapter that is opening that will be focused onto analytics of convolutional neural network and graph applications. And what happened in 2017, for example, this is a very interesting one. This one I mentioned before, the question of the representation of the numbers. For example, modify the floating point representation 16 data format. And this was particularly, gave rise to 1 or 2 publications. And neural machine translation, for example, is another one that was the code Marion. I don't know if any of you know it. Has been ported successfully onto the Intel CPUs with a big improvement of scalability for this framework. Again, which is we want into these collaborations around the library to push the frontiers with the leading scientists. Okay, I'm going to finish. I don't know how long I still have for my presentation. Yeah, just to give a slightly different pitch. Since this is Women in Data Science, I'm taking the opportunity also maybe to give a little bit of highlight about what we do as a company in the area for facilitating also the capacity for women and underrepresented, let's say, group into technical profession. So myself, when I did my PhD a long time ago, but already even in high school, I think the ratio was really more like probably 1 to 8, 1 to 10. And it's not often indeed that we are in front of audiences like this one, as one of the speakers explained. I think things have changed since then, but they have not all changed, but things have changed. So my thought is the following. Even that in some of this is a citation from somebody in 2014, in most technical companies, the women represent more or less, let's say, 1/3 of the employee, 15% of the position, 23% of senior level. It might be slightly different at Intel, but not very different. And indeed, this person mentioned that the gender balance is still pronounced. So we have to do something, and we feel that we have to do something also because it's in the interest of everyone. It's in the interest of the capacity, because women, of course, all the whole population are potential users, buyers, deciders when to buy things from a new TV to a new car that are technology based. So for example, They represent, you see, the purchasing power, slightly higher. This was a study from 2010. It may have changed a little bit, but not much. The essence of the message is still there. However, we have 20% of the Fortune 250 CIOs are women. It may grow 10% every year. And the women represent only 25% of computer information and system manager and so on and so forth. An example, we have heard and we know that, for example, the design of the intelligent car is a very, very large business, very interesting one. It's not only a business, I think it will be a change in the way we use things such as the car that we have been using for the past almost 100 years now. And so there are many, many developments, including from, of course, companies such as Intel. But there are many very interesting developments because developing an intelligent car requires actually to have access to many different things from, the design of the car, which used to be done before, let's say, in the simulation area. You had siloed against simulation, then you had the production, and then you have the maintenance of the cars. To go up to an autonomous car, you need to integrate all the data, all the knowledge of all these different areas, and you need also to backfeed the loop, of course, to make the car intelligence enough to drive by itself, to go by itself. I don't know if we will reach this and how quickly, but I'm certainly confident that I want to have a car that is being developed, conceived, and designed by the biggest representation of the population and not 2 minutes. Yes, I'm done. I am done. So what I want to say is that, for example, at events such as high-performance computing, both in Europe, which takes place every year in Germany, or in the US, rotates between different states in the US. Intel, we always host, since a few years, a number of events to promote technical professions, scientific professions, especially towards minority that may not be represented, may not choose necessarily to participate into these activities. So if you happen to be in one of them, please come and see us. And I wanted to finish my talk by saying that there is an open call. Intel is with ACM SIG HPC promoting a fellowship. I can give the link to people if you're interested. The nominations are open until April 3rd, and we welcome really. The idea is to support underrepresented groups to pursue advanced degrees in computation data science. So this is one example of the kind of work that we do with the community, very different than the technical one, but certainly very useful, we hope, and it's important to us. Thank you very much.